Okay, ich denke, ich bin live. Hey everyone, how are you doing? I'm a bit, I have a little cold, so my voice is not peak performance. So let's see how the talk goes. Today we will be talking about GraphQL and especially building GraphQL, building modern applications with GraphQL. What modern applications are, I will walk you through that as we go along. Before we get started, let's do a quick quiz of the audience to see where everybody is around GraphQL. Just 2 questions. So if you have a phone, just scan this QR code, or you can just choose the link down here. I'm already going over to my other side here. And I know there's a delay, so I wait a couple of seconds for people to catch up and join in. Okay, that's the first person. That's good. At least one is watching. Give a couple more seconds for people to join. Yeah. Yeah, you can also send icons there. These little emojis. Okay, 5 people. Let's go. Wait one. Let's wait 10 more seconds so a couple more people can come in. That works much better in a live audience where you sit in the same room with the attendees because you don't have any delays. But okay, let's move along. Have you used GraphQL before? You don't know it, you heard about it, experimented with it, or have it in production? So, okay, there's a clear column here of people who heard about it. Interesting. Okay, at least one experimented with it. Let's give it 30 more seconds. We'll see if there's a difference. Okay, let's move along. How old do you think GraphQL is? It's a typical question, and most people get it wrong. But what do you think is the age of GraphQL? Okay, 50-50. So, I'm not showing you the correct answer yet. Let's head back to the slides. 2012 was the year GraphQL was created, was shipped to production. So not only that it was the idea created, Facebook probably started working on GraphQL in 2010. Why the 5-year answer is also kind of correct is because Facebook released GraphQL to the open source ecosystem in 2016. They announced it in 2015. So that's why many people think 5 years, but actually GraphQL is a very solid technology already. Facebook used it first 5 years, you could say, made sure that it works out and that it works at their scale, and then they shipped it. The first name of GraphQL internally was Supergraph, for lack of a better name, and it was created by 3 developers, Lee Byron, Dan Schaffner, and Nick Schrock, all from Facebook. Okay, what is GraphQL? That's a typical question, and since everybody just heard about it here, except one, let's dive into that. Before we can answer that, let's think about why is GraphQL? And that answers also a lot of questions. Why is GraphQL so good? It's because Facebook developed it for a certain need they had. This is the Facebook application, the mobile application on iOS that you have today. Actually, back a couple of years, 2010 to 2012, it looked more like, not like this. Do we have the crappy version? That is the application, how it actually looked like. And a lot of people had problems with the app. And there were three main issues that people reported. It had a sluggish response time. So if you started the Facebook app, it was really, really slow. And it used a lot of data. And back in the days, like we didn't have these unlimited data plans. We had maybe 500 megabytes of free download capacity, but even then we had one of the big plans, right? We didn't have a lot of free data usage back then. It also drained the batteries of the mobile applications really quickly. So the Facebook engineers then sat down and looked at what the problem actually is with this mobile application. So what they found out is that Facebook actually betted on HTML5. They wanted to build the application with all the web technologies that they used from the web. So they took all of that and essentially initially had a wrapper of an application around HTML and used REST in the backend, because that was what they used in for the web application. And while even Steve Jobs back in the days betted on HTML5, they were all too early. Not that they were essentially wrong. So they found also out that the main issue that they had was their REST API. So here's a fun fact. The API graph.facebook.com is not a GraphQL API. It's actually their REST API. And the API looked something like this. I copied a bit from their documentation here. And they found out that they did a lot of data calls when their application started. And this has something to do with how the desktop or the web version was built. So when they logged into or opened the application, they would do a call, a REST call to the me endpoint. And the me endpoint would give back a couple of properties. It's around 50 properties that this API returned, but they just needed 3. So they took these 3 properties that they needed, stored them in their application, and most important was the ID from the current user, because with this ID they could do another call to another REST API, and that was the newsfeed. So the news API then returned a couple of data, again a list of news stories. Again, they had a couple more properties than I show you here. Again, think about 60 to 50 properties here that they fetched per story. And again, they just needed maybe 4 of these properties. And especially they needed the IDs. And they took these IDs and made the next call to collect the comments for this thing. So each news story had comments to them. So they started fetching these. They took the news ID and started fetching comments. Again, we had more properties than we needed on the mobile application because the web application just had so much more going on. And if you remember the picture that I had there, the screenshot of the mobile application, we had just a very small screen, so we couldn't put all the content anywhere there, even if we wanted to. So it was much more limited, a different use case. Last but not least, they went on and fetched the authors. So they collected all the authors ID and then they fetched the authors. Again, that is the same object than we had for me with these 50 properties that we don't need. Okay. So what this must have looked like if you looked at the developer tools is something like this. We call that a data waterfall, where we have consecutive requests or requests that depend on other requests. And this is bad in the sense that we have a blocking thing going on here where we cannot parallelize these calls because we always need the IDs from previous calls. So the Facebook engineers then sat down, and actually they didn't plan for a revolution. They actually thought about what to make better in their REST API to get to the point that this is more efficient. So the main essence here is that every client has different problems. Every use case has different needs for data fetching. When we think about that, like I said, it's not a revolution. At this time, a lot of companies were thinking the same thing. Like Netflix was trying to introduce something very similar to GraphQL. They actually had a couple of attempts. They had, for instance, this Java API, which tried to have like a lot of BFFs, backend for front ends, for their different mobile devices. Like Xbox had different APIs than, for instance, the iPhone or the Nintendo. So it was not just that Facebook looked into that problem, it was actually a couple of companies that digged into the same issue in here. But Facebook came up with GraphQL, and it won over companies like Netflix and others because it was so simple. In Facebook, we shifted the paradigm. We didn't build a specific BFF, a specific web API for a specific use case. We just let the client define what data it needs. So if you started, for instance, this initial Facebook application and you just need the current user and the name, then you ask the backend for that. And this is a typical GraphQL query I have here. It asks for the currently signed in user, me, and the name. And if I send that to a GraphQL server, I get a response back that is closely aligned to my request structure. You could say, and it's wrong, that we send an empty JSON graph into the GraphQL server, and the GraphQL server fills it up. So it's wrong, and you will see as we go along, but it's a good mental picture to start thinking about GraphQL. So as our use cases change, as our devices change, we can ask for more or less data. In this instance, we are asking for the profile picture of the user and some properties around the profile picture of that user. And if we send that to our GraphQL server, again, we get a response that is closely aligned to our request structure. So we never get more properties. We always get only what you asked for. And reflecting on that, GraphQL is not about sparse fields. It's about trees of data. And that makes it so great with relations. Think about it. We can, for instance, ask for the currently signed in user, but at the same time also ask for the friends lists of this user. Specific Facebook use case here. And then the server can resolve that much more efficiently because we don't have these round trips. Think about these round trips where I get the ID, then I send another request to the server just to get the data back that I could have gotten in one call from my database. But now I have all these HTTP round trips. I don't have to have that with GraphQL. But there's also some repetition here, and that is name and last seen. Me, for instance, is a user object, and friends is a list of users. And in GraphQL, we have a concept for that, and that is a fragment. So a fragment is essentially a data component. It's about componentization of the data and for the front-end structures. So essentially, a UI component could declare a fragment as a data contract. So that is a data contract of a UI component. And you can use that to build component hierarchies as you build component hierarchies in your UI frameworks or class structures in your backends. So it's a way to componentize your data needs, essentially. Okay, let's move on. So the essence here is GraphQL gives clients the power to ask for exactly what they need and nothing more. So what is GraphQL? GraphQL is essentially a query language for your API, and it's a runtime to fulfill those queries. And that makes it fundamentally different from something like the OpenAPI specification, like, for instance, Swagger or things like that. But we will see as we move further. So with GraphQL, I just have one endpoint. So I don't have these resources like in REST, where I try to have, for instance, a user resource or a news resource, to have these silos. I just have one endpoint because I can request in whatever GraphQL query structure the data I really need for a use case. So I can ask for all the data that I need for a specific use case or for a specific client in one request. And that makes it super efficient. There's no over or underfetching in GraphQL. Overfetching is always when I get these 50 properties that I don't need. And underfetching goes hand in hand with overfetching, because you remember all these IDs I pointed out. I had to fetch an ID for my user to just feed into another request to get some other data. We call that underfetching because I don't want this ID. I actually want this other data. And with GraphQL, we don't have that anymore because we can dig into relations. And in GraphQL, we have a type system, like in C#. We have interfaces. We have essentially classes. We call them object types. We have scalars. We have unions. We don't even have unions in C#. So we have a very strong type system that makes sure that we cannot violate the contract between client and server. And that makes GraphQL really predictable to use for the consumer. On top of that, GraphQL is real time, and we also have a look at that as we go along this talk. So before we see the first bits of code, let me just give you a couple more information about the structure of GraphQL. We have essentially three operations. We have read operations. We call them queries in GraphQL, and it's the get in REST. And then we have write operations with our mutations, and it's the put, post, patch, delete. I never knew what to pick, but don't care about it. It's just a mutation. If you delete something or if you create something, it's a mutation. And then we have something called events, which is called subscriptions in GraphQL, and we don't have that actually in REST. I mean, you have things like SignalR, but this is a different thing, and you will see as we go along that writing a simple query is the same as writing a simple real-time query and getting the data in real time. So we are going from 0 to 0 here. So we start with queries. And let me actually start with the simplest thing to do. So how do we get from a web server to a GraphQL server? So the first thing is let's create a new web application. So I'm doing .NET new web here. Just check which version we are running on. Okay, it's already 7. I was not sure. Okay, so this is a simple minimal API here, and it's just one endpoint. It's not even REST. I would say it's just something listening to an endpoint and printing hello world. And we can just .NET watch that as we transform that into, oh no, hot reload. Okay. As we transform that into a GraphQL server. So at this point, and let me just drag that in, we just have this hello world here. Let me pin that, okay. And now we transform that into a GraphQL server. So the GraphQL server is about these root types, I said. And we want to create a query root type. So we create a class, and we call that query. Very simple. And since we want to do a hello world here, we create a method here which returns a string, and let's call it, say, hello. And this method actually has also a name. Very simple. And the name actually, let's give it a default and call that world. Okay. And then we do just a simple string function here to concat our hello world string with the argument that we passed in. And that is already a nice function for our first GraphQL code here. So that is an operation type, we would say. And now let's make it a GraphQL server. To make it a GraphQL server, we first need a second package here. And that is the hot chocolate ASP.NET Core package. So we say .NET add package. And then we say hot chocolate ASP.NET Core. And I'm using the newest preview that we have. Did it work? It's in here. So if you compare the projects here, as the CS proj here, it's just added. It just added essentially one package. Okay. So now with this package in, we can use the builder here and then say services, and then add GraphQL server. Like that. And then we can say add query type. That's the root type we declared, and add that to our GraphQL server. Okay, with this, actually our GraphQL server is running, but we need a transport middleware to actually communicate with our GraphQL server. So what we're going to do is map GraphQL down here on the app, and then we are good to go. Our GraphQL server should have rebuilt already. Let's make sure. Let's do another save. Yeah, it's building. And then let's grab our browser again. And then we go to the GraphQL route, because GraphQL by default hosts on the GraphQL route. That's the HTTP specification for GraphQL. It says host GraphQL on the GraphQL route. So the root is now a 404. And we call the GraphQL route here. And then we are greeted with banana cake pop. So hot chocolate is our server, banana cake pop our GraphQL IDE, and our GraphQL client is actually called Strawberry Shake. Don't ask me about the names, or do if you want. So, and the most important feature here for this by this IDE is that we can take off the glasses, but okay, anyway. Let's start exploring our GraphQL server a bit. So I'm opening a new tab here, and I could now just write GraphQL queries here, but let's explore the schema a bit. So I'm going here on schema reference, and then you can see that we have a query type, and this query type actually says hello, and we return a string type, and we have here an argument that's name, and is also a string, a non-nullable string, and it has a default of word. So our C# API translated one-to-one to GraphQL. So, and we could now also just query that. So we could say hello world, and we execute that, and then we get hello world. And if we wanted to specify, for instance, the name, I could say Michael here, and then execute that, and then I get hello Michael. So very, very simple to get started with GraphQL. Okay, let's do one more thing here before we move to the next example. And that is, let's maybe add an author and maybe add a book. These are the basics, okay? Just so you have an idea of how objects actually translate to GraphQL. So I could just do a book here, get book, and then we return a new book. Actually, I have the resolver prepared here. I don't want to bore you with typing. John Skeet, C# in depth. Let's go back to our GraphQL IDE, refresh that, and then we go here to our schema resolver, and then you have a books here. Why not get books? In GraphQL, we don't use these verbs. That's why we GraphQLify your C# API, but it's essentially we have the translation of your C# API. And we can drill into the book here. You can see that. And then I can drill also into the author. Very nice. Okay, and I can also query both things together. So everything that the server exposes on the query type, I can dig into. And that is nice. If I just want the author name of the books, then I just get the author name of the books. If I want the title, I get the title as well. Okay, with this, let me get rid of that. Let's move on. That was demo 1. And let's reflect on that. So this was a class I wrote initially, and we call this the root operation type query. And this guy here, we call a resolver. That resolves data for our GraphQL API. And this translates actually into a GraphQL type. And you can see it translates very well into GraphQL. So we call that the annotation-based approach. It's the original approach with which Facebook built their first GraphQL server. The first GraphQL server was built in Hack. And exactly, we said that. And we call these guys here fields in GraphQL. And fields are like methods in C#. They can have arguments, and they can have default values. And they can even have more complex default values than we can have in C#. For instance, they can have object structures there. We cannot have that in C# as a default value. And this guy here, you see the bang operator, that is the non-null marker in GraphQL. So it's reverse. In C#, types, when we just say string, it's non-nullable. And in GraphQL, just string would be nullable. Whereas in C# question mark to the type means that it becomes a nullable type, where in GraphQL exclamation mark to the type makes it non-nullable. Okay, GraphQL lets us model an interface to our core domain. And that's the main theme that Facebook had. So they had their internal business layer. They had their business layer that they used already with their REST API. And when I said in the beginning it was not a revolution, but an evolution, they just took the chance to build the first version of GraphQL to be a fancy sparse type thing, I would say. And then it developed from there further and further into the GraphQL we know from today. And because GraphQL has this strong type system now, it gives you a chance to expose your API in a way you never could with REST, because you always had to think about serialization. How does it translate into my DTOs? You had to essentially take the richness out of your API. Yeah, that's another thing. GraphQL actually lets you expose your business layer in a much richer way. That's what I meant with my comments before. So let's talk about transport here. GraphQL transport, people say, what is this using? Are you using because it's real time? Are you using sockets or whatever? So actually, GraphQL uses mostly HTTP. The predominant thing is HTTP post. Actually, also subscription work over HTTP post if you use server-side events. You can also use gRPC as a transport. As I said, GraphQL is transport agnostic. And the first GraphQL spec didn't even talk about transport. But these are the common things: HTTP post for query and mutation, and now subscriptions with server-side events. You can also use WebSockets for subscriptions. That is actually what most people use today. But just because server-side events and HTTP2 was not yet a thing. So today, I would reevaluate the decision on these things. Okay. When I talk about modern applications, what is a modern application? Let me show you something. And let me just pick up a new browser window here. And this is essentially a GraphQL application that we built to teach. So this is a GraphQL application, and it's modern. Why is it modern? Because it's reactive. It is super fast. You can see every number here moves. And it's not that we have a lot of calls here. Let me have a look at the developer tools here. Then let's go to the fetch. and the network layer. Just a second, let me make that in here. And then we, for instance, refetch. Let me do that. Okay, so this is one call, and it essentially is on an Azure function, and it's at the moment not so fast, but it should be. But it's one call. But anything that you do on this application is exactly one call. So if I go here to the Bitcoin, it's one call. If I do a switch here on my tab, it's one call. No matter what you do, it's always one call. So, and that means we don't have a lot of network things going on. If you go to REST applications, you always see tons of calls. And so in a modern application, we want it to be reactive, we want it to be componentized, and we want it to be aware of the types from server to front end. So we talk about type emission and things like that. And if we look at these requests, actually, we can see that the server asks here for all the data it needs. I could take that, and then we could run that also on our backend. But let's move on. We actually built in this talk the backend for this application with all the real-timeness to it. And then we can iterate on what a modern application is more. So in a modern application, we want a fast iteration speed between front end and back end. We want strong contracts, meaning the contracts of the back end translate to the contracts of the front end. We want static typing in both things. Then we want efficient data fetching, like with GraphQL, and we want to empower our consumer of our backend. And that is really important because our consumer in GraphQL, the front-end developer, is very precious. So it actually, I sometimes joke about it, but it makes the relationship between front-end and developers much better. Front-end and back-end developers much better. And on top of that, modern applications for me are reactive. They really are engaging in the way that data lives. Okay, let's see how we can fetch data with GraphQL. That is our demo 2. It's lots of code. Okay. Into it. So this is the base for the base backend for the application I showed you. And let me just restore it, and then I can walk you through. So here we have the data layer, and the data layer at the moment has here the asset. That is our cryptocurrency that we display in the application. And we have another entity, which is the asset price. So all the prices that you see, don't sell your Bitcoins or whatever. They are captured a couple of months ago, so they are fake. So what we want to do here is expose our entity framework data here with GraphQL. And to do that, we will introduce a type that we already did in the first application, and that's our query type. Okay? And in this query type, we're going to introduce a new thing that we call a resolver. And this resolver returns just the assets. So essentially, we grab the data from our asset context here. And you can see that we are passing the asset context in our method here. We call that resolver dependency injection, because GraphQL is built to parallelize the execution of resolvers. And Entity Framework, for instance, if you think about it, is not made for parallel threads. But we can inject rented DB context into the resolver, and by that making parallelization possible. In this case, we just return the set ordered as a queryable. So how do we hook that up? You can already see I'm using here a pool DB context, and I just have to add the query here, query type. And then I have to essentially tell our engine that there is a DB context, I'm going to do that, and that's the asset context. So, and we tell our engine about it because we're going to tell about the behavior of this thing. It could be that we have the standard DB context where we have to synchronize. Essentially, we cannot execute in parallel. Or we have a pooled like this where we can parallelize. Or we have essentially, again, scoped DB context where we branch the whole dependency injection around it. In our case, we're going to use the pooled one, and then we're going to run this. Which is better. Okay. Again, I need a new browser, I think. Okay, we missed something. Let me quickly figure that out. Ah, yes. I know. Okay, so I prepared that in the way that I actually don't have my type in here. Let's move that out quickly and move it in the namespace in demo.types, because I'm using global namespaces. As we go forward with this example, there's a couple more things we want to do. Is it compiling? Waiting for file to change. Okay. Fix that. Well, don't know how to build. It works. Doesn't work. Why not? Always when you have demos like that, but we need to fix it because on top of this demo. Okay, it works. Somehow there was an artifact left in the bin folders. Okay, this is the same banana cake pop we saw before. Now we have this new API that we just built with this query type. And what you can see is, and you might expect that already, we have actually here our assets. We can drill into that. We can also drill into the subtypes here, the price, for instance, and we could also query this thing. So we could write a simple query, fetch our assets and, for instance, the asset names here, and then execute that. And then we see, oh, damn it, that's the whole database. And that's the right time to talk about paging. So when Facebook thought about GraphQL and rethought their concepts about data fetching, they also rethought about paging. So the typical paging that we do is offset-based pagination. But the problem is there that for Facebook, that all the data that they came into their newsfeed rapidly could make you page essentially on the same page. Think about it. You are on page 1. And now you want to go to page 2, but new data came in rapidly. And now you have parts of page 1 and page 2 again. Typical problem. Or you completely repeated the page. So what they came up with is something they call cursor-based pagination. And with cursor-based pagination, we are pinning the entity. So we navigate relatively to an entity. And with this, we don't have the problem anymore of these incoming data that essentially makes me page 2 times the same page, because we are moving with the items, navigating relatively to the items. So let's have a look at how we can do that in Hot Chocolate. So when I'm in my GraphQL query type that we have here, and I want to make it pageable, I'm going to add this thing here, use paging, and then it's pageable. So it was not about the implementation here. It was more about the concept. And let's start watch again. I hope that works because there's so much more. Okay, and now if I refresh that, you can see that this is wrong because we now have a paging structure here. And I'm going now in the column view because it's better to see in there. So I have here my assets field, and that returns actually an asset connection. And the asset connection, and that is essentially the graph-related stuff here that we have. We call them edges, like in a graph, my edges. And that was a typical thing this connection pagination specification started with, that we had for each item. You can see here, node is an asset. We had a cursor, so we could branch from every item, the set. Nowadays, we have a simplified version of that. That's the nodes field here, so we can directly get the assets. And then we can use the paging info, which has the start or end cursor. That's the cursor of the last or first item. So let me write a simple query to page a little bit here. So we would essentially go for nodes, and then take the name here because we wanted to page into the name. And then we have something like the paging info here. And we, for instance, if we wanted to implement a fast forward paging, we could ask for has it a next page, and give me the end cursor. That's the cursor of the last item. So in order to see better here, let's take the first two items. We execute that. You get the first two items here, Bitcoin and Cardano. And this is the end cursor, and that's the cursor of the Cardano. If I feed that now into my function here, because we have a couple of arguments, you can see first, that's how many items I want to take. And then we have, for instance, after. We want the first two after this cursor here. And I can just copy that in, and then execute, and I get the next items. So in the cursor typically is the ID or some key set that identifies this item in your data set. Okay, and I could now paginate forwards with this very easily. I could also splice data, and you saw there first, after. I could also ask for the last two items after this cursor, or for the last two items before that cursor. Okay, that's all about paging. Let's move on. That we did. And that's the right time to talk about middleware. So we in Hot Chocolate have a lot of middleware, and we actually adopted this concept from ASP.NET Core initially and from Node. And this is actually how paging works. So if we put a use paging attribute on top of our resolver, it essentially forms a middleware pipeline where the resolver becomes a middleware. So that's just the last middleware in our pipeline. And use paging becomes the first middleware. But there are a couple more middlewares that we actually have, and that is use projection, use filtering, and use sorting. So here's the thing. These things have to be used with careful deliberation, I would say. So let me first show you that. So we could go here and we could opt into these data middlewares. For that, we would need to go to the GraphQL configuration here and then opt into these, because these are opt-in things. So I could say add filtering. And now Hot Chocolate has support for filtering. I could say add sorting. Now we have support for sorting, and let's also add projections just to have them all in here. And I could go then here and essentially web that into my resolver pipeline here. Say use projections, then use filtering, and then use sorting. Let's just first have a look at what it does, and then we discuss what is good and not good. So actually, if I just execute that, nothing changed. It just executes. And by the way, the more expensive startup time, that is essentially schema building time, because you can pre-build your schema when your server starts, and then you don't have the cost on the first request. I didn't do that in my demo here. That's why the first request always has the cost, the expensive cost of building the schema. Okay. Second thing is that if we go in the schema reference, you see that now we have a couple more things, or we should have a couple more things there. Refresh, a couple more things here, like where and order. And that is where we now could, for instance, order our set, and then we could say, for instance, we order by the price, and where the coin has the highest price. Get rid of this guy here. We want to get the first items with the highest price, so we say last price. Then we take a descending order. Then we execute and we get the Bitcoin in Cardano because Bitcoin has the highest price. That was clear. But this is now interesting. How does it actually translate? So let's have a look at this here. And you can see that we have a perfect SQL representation because the GraphQL query now translated one-to-one to our SQL query. And that is actually where you have to be careful. Don't just do it like that. So typically, I would limit my filtering, limit my sorting, and we have for this the filter input types. So you could say I want to have an asset sort input, and that's the sort input type. And then I could essentially say this is for asset, and then I could limit which fields are actually sortable. So there is a configure method here. And I could dig in and say I only want to bind fields explicitly for this sorting thing, and only allow this thing to order actually by the price field. It makes no sense in my example here, but the idea here is that you limit these things to things that are indexed. Otherwise, you get into trouble. Also, you always have to think about, do I want to couple my GraphQL API so closely to the database? You can do that. And for some projects, it makes sense. Other projects already have a very nice business layer and then really expose this the business layer. Much better way to do it then. But it always depends on your business needs. And so it's up to you. So how these middlewares work is very simple. It's the same thing like in ASP.NET Core. We essentially have this middleware pattern where we have these factory delegates where we pass next in. Next is always the next element. And that is delegate to call the next element. And then when the first middleware is invoked, it essentially calls next. This also calls the next until we hit the resolver. And the resolver returns a queryable, and then the sorting will essentially traverse the GraphQL query and rewrite it into an expression tree. And the expression tree is then applied to the queryable. And the queryable with this expression tree applied to it is passed on as a result. And this goes on and on until we go to the paging middleware, which then slices the data. So a GraphQL query like this then translates really one-to-one to an SQL query like that. And we just added also a lot of more database drivers. So everything entity framework, then RavenDB is coming in a couple of weeks. And we also have just added MartinDB for people that like Postgres and the MartinDB libraries. Okay, let's move on. We already did that. I applied them. So let's skip over that. That was essentially adding just these attributes on top and getting these data integrations. As I said, if you have a proper business layer, always think about, do I want that? And be careful with these filters. Just apply them where they make sense. Don't just apply them and expose everything to be filtered, especially with large text fields. Okay. Let's talk about REST. As we talked about now, it was essentially GraphQL in the data layer, but GraphQL historically was built on top of the business layer, on a proper business layer. And as GraphQL evolved, it became a gateway technology where you have a GraphQL on top of your old infrastructure. So typically when Facebook open sourced it, the JavaScript community went wild and said, okay, screw these backend developers, they make shitty REST APIs. We GraphQLify it. We put GraphQL in front of the REST APIs, and then we have a nice GraphQL API. And we can use GraphQL, and they can do their thing. We don't care. And that essentially was how GraphQL became very popular very quickly in the JavaScript ecosystem. Okay, so in our case, we want to also integrate into our asset service now price data from a REST API. And in this case, we don't want to rewrite the REST API, and we don't want to generate any code for it. We just want to integrate it. So our REST API, this guy here, if we call it, we get a response like this. We just want the percentage change, and we want the percentage change to be merged into our API. Let's have a look at how we can do that. And let me get rid of this demo. And let's pull up the next one, which is demo 3. Okay. So this essentially is the same API, the backend, just a bit more evolved. You can see there are a couple more things to it, but in essence, it's the API we were just building. So let's talk about integrating that. At the moment, I reorganized my API here. Now I have a couple of topic folders here. So assets is where I have everything related to the assets or the asset price. And then I also have now user objects here. So the interesting thing is we want to have this REST API. And we already have here a REST endpoint declared. So that's the HTTP client. I call that the price info service here. And as far as this guy here, we have not a lot put in here. So let's get that thing in. So I'm adding now a GraphQL file. Let me do that. That's a schema.graphql here. Put it in root. And in the root here, and then we're gonna add a typing to that. And let me just see, I already prepared that. This is the this is an object type, so the same thing as the asset is. So we translate the asset, our class, into the same type structure than I defined here. So I declare here essentially that I want a type. That's the asset price change, and that has a percentage change, and that percentage change is a float, and this comes from some JSON object that we will fetch. Okay, with this I essentially made my GraphQL API complete. I need to register that. We call that SDL first. In Hot Chocolate, you can actually combine all these approaches. There's code first. There's schema first, and there's annotation based, which is the original GraphQL approach. So while I like most annotation based, many people also like schema first. You can use it. So in order to add these schema first things into our GraphQL types here, we just do add document from file here in this instance, and then we're gonna pick that schema.graphql. And then essentially our type would work now, but we need a resolver to connect this thing. So we're gonna go to the type which we want to extend, and that is the asset price node here. And there we want to add now a resolver that fetches this data from REST. And in this case, we're gonna take add here the resolver that uses a DataLoader. I didn't introduce the DataLoader concept yet, so let's do that. And then I'll walk you through the code actually, but let me first give you the background here. So actually fetching from a REST API is expensive. And if you think about that, we have the assets here, and then we fetch the price. And then for each price, we fetch price change, this percentage change, that could be a lot of calls to our REST API. So what Facebook came up with was the so-called preparables, or what they today call the DataLoader. Preparables were essentially built around the concept that we had before we had task async, like where you have this begin data fetching, and then at some point you call this end data fetching. I don't know if somebody remembers the times around .NET 1 and 2, but let's go. So with the async pattern, it transforms then into the data loader. So what it essentially does, instead of doing the data request or the HTTP request here, we're going to call something called the data loader. And the data loader will then batch all these calls. And that works by essentially cheating a bit. So the resolver would call the data loader with a key. In this case, the key pair is Bitcoin and months. So we want the percentage change for the Bitcoins aggregated over a month. And we would ask the data loader. And the data loader actually has something called a task cache. And the task cache, and when you ask the data loader, it would essentially look into its task cache if there is some task lying around for this combination of key value, for this combination of keys here. If not, the data loader would create a new task. Actually, the JavaScript term is better because it would create a promise. And that's what the task is. We are creating a promise for something that we don't have yet and give that to the resolver so the resolver can wait on it. So now the execution engine executes all the resolvers that it can execute until it essentially deadlocks, because all the resolvers now await a task that has no data to it. And at this point, the data loader would be invoked by the execution engine, which says, I'm completely deadlocked. I cannot move on. Please fetch now the data. And then the data loader will go to the price change service and fetch essentially all the data in one call. Okay, granted, your REST API needs to be able to fetch this data in batches. So in our case, we allowed that because we essentially updated our REST API here and said, okay, we are now able to pass on symbols, multiple symbols here, for instance, the Bitcoin and the ADA, and then get multiple of these guys at once. And this improves data fetching, but also ensures consistency in a large graph where essentially it's guaranteed that data, once you have fetched it, doesn't change if you do a second fetch. Okay, let's have a look at that. So in our instance, we have here an asset price change data loader that we inject here. And we also have an argument. That's a price change argument. And we also get the parent to which we essentially extend. This resolver here extends our asset price entity. So we don't have to actually change any object for our entity framework. This is GraphQL specific code. It's not attached to or changes our business layer. So in this case, we create here a key. And that is just a record struct here that we use. So a key for a data loader must implement equals. And then you can use it as a key. In this case, we combine here symbol and span as a key. And then this data loader, let's have a look at that. Actually, not this guy. It's down here. That's the asset. This guy does all the heavy lifting. So that's the data fetching code here where we get all the keys from the execution engine. So a data loader looks something like this. This is an HTTP batch data loader here, gets in a key, and then it will return for us a list of or dictionary of JSON objects with keys. And essentially the execution engine gives it all the keys that it has to fetch, and then it can craft a REST request with all these keys here. Okay, let's have a look at how that performs actually. Okay. Watch hot reload. I hope it works. And I didn't forget anything to put together, but it should. So the first thing, let's go into our GraphQL IDE here. We refresh our schema, and then we're going to have a look. You can see it has a lot more things to it now. And we can go here to our asset, then asset price. And then you see here, this field change. That is actually coming from REST, not from our database. And if I look into that, it has an argument called the change span. That is essentially an enum. And we get back the asset price change, which is just the aggregated data. So let's execute that. So we're gonna dig in, fetch the price here, fetch the last price, and then we go in the price change and go into the aggregation here. And if I fetch that, then you can see that I get this data relatively quickly. 1 second here, first call, second call is 63 milliseconds. First call, as I always said, has some overhead to craft the schema, but all the other calls are pretty fast now. And if we look at that, you can see that we fetched all the data in one REST call here. Awesome. Pretty simple concept, but it's very powerful. Okay. That was optimizing our REST API with DataLoader. Essentially, it showed you we just need to type the data for REST, and then we can already integrate it in our GraphQL API with all the GraphQL guarantees. And then we do put some DataLoader in to make it fast. Okay, let's talk about real-time data. So we talked about read operations. I'm not talking about mutations today because they are very similar to queries. There's some specifics to it, but I don't want to end up in 2 hours talking about GraphQL. And there's another GraphQL talk after mine, so I don't want to steal too much time. But real-time data is a must. So when we talk about real-time data, as I said, it's very similar to queries, but we don't talk about a simple request and response. We more talk about something called a response stream. So we have a stream of responses. And we also talk about event streams. So let's have a quick look at how we could implement that. So kicking that out, and then we go on to demo 4. Quickly refresh that here. And restore. Okay, same application, just a couple of iterations ahead, you could say. We have the REST integrated. A ton more REST is actually integrated. A couple of downstream REST services are integrated in this one. But we also now want to integrate a real-time event for the pricing here. So let me show you how to implement, and that's already a complex event. Maybe I show you first how easy it is to put a subscription event together, and then we actually make the price calls real time, so we can get real-time data like you saw in the application that I showed you initially. So let's introduce the basic frame here, and that is just a class we call asset subscriptions. And that is something I didn't show you before. So with Hot Chocolate, starting with version 12, we introduced a concept of extending types. And that means because these types, like these query types, they could get large. Yeah, and we now allow to split them. And that is essentially a concept of type extensions, where you have, for instance, the asset queries that are all the query root fields for the query type, but just for the topic asset. And then we just hint to which type these fields should be stitched in. Okay, the same as here for subscription. I now have asset subscriptions. These are subscriptions that are for the topic asset. And it allows me essentially to move these types into a separate library if I wanted to. So just as a background why this is not just called subscriptions here. Okay. the next thing to have a subscription, so the easiest way to create a subscription is essentially to create a resolver. Let's, for instance, create a simple send and receive thing for a message. So we return a string here and say on receive, and then we have something coming into it, and that's the message. And actually, that is not an argument, but this is our event message. Awesome. And in our case, we just return this event message. And to make that real time, we just put the subscribe directive on it. And then this is a subscribe resolver. Okay. So the second thing is, so the typical thing what people do with these subscriptions, and that's not what I do in later on, is they essentially introduce mutations that trigger subscriptions. Like in our case, let's just add a simple mutation here. Let's call this simple mutation, maybe it just returns a bool, which indicates a success, and then we say send message. And that gets in the message. And to essentially make that a real-time trigger, we can inject here something, a service. We mark it as a service, and it's a topic event sender, and that's the internal abstraction for the pub subsystem, which is behind the real-time events. So we call that in a sender here, and this must be a task in this case. And this guy is async. And then we could send this to the sender. So we could send async. We could come up with a topic called messages here, for instance. That's quite small. And then we could send in the message. Await this, and then return true. Okay. So this is a basic setup for a pub sub system. Since we are using mutation conventions here, I'm not going to explain it, but I'm going to rename the payload field name here so it makes sense. And then let's just have a look at that. And then we make it really real time with our price event. So let's refresh that here. Let's wipe that out. And actually, let's create a second browser here on the same client. So the first one, we're going to subscribe. So in order to do a subscription, and that's why it's so beautiful to use, it's the same like you do with a query. So a typical query is actually started in a clean request. We would start with query here, right? And typically also with a name. That's the operation name. So a typical query would look something like this: get assets, and it's kind of like a method. And everything in here is what you want to execute. So a subscription is essentially written the same way. We started with subscription here, and then we can just query for this real-time event. In this instance, it's on receive. And then we can just execute it. But it doesn't give us anything. It just waits now for incoming things. So in our second window, I'm going to write this mutation. And the mutation is essentially the same thing like the query. We start just with the keyword mutation here. And then we are going to look for the send message mutation, which gives us, or which lets us specify a message here. We just say hello. And then we execute that. And it should actually come back here. That is not the case. Typical fail of my demo. And it shouldn't actually, because the keen-eyed maybe have seen that I specified down here that the topic is messages, right? And I have to specify the same on my asset subscription here. So I have to specify a topic and have to bring these together. Like this is actually the topic messages. Let's rebuild that. And then let's rerun that. Actually, the other one. On this one, I think it's wrong. There is something very strange. Subscription, but we'll manage. Okay, so we are waiting here for our subscription. I'm going here, sending that in, and you can see the subscription message just appears. And that is real-time events, so driven by mutations. So this is actually not what I want to show you. Just I wanted to show you the minimal way to put a subscription together is actually pretty simple. We just put these things together with our internal messaging bus, and it works. So in our case, we actually want to do something different. So let's wipe that out. And I'm already 10 minutes over. I'm very sorry, but I'm almost done. Okay, so what we want to do is introduce here a proper message stream. So I said something about an event stream. An event stream is actually represented by an async enumerable. So we don't have to use the internal hot chocolate abstractions here. We could also say we have a real event stream somewhere in Kafka or whatever, and we subscribe to that here. We read from that, and then we yield back the payload, the message payload, the event payload. And that is essentially our event stream now. So then we have to introduce the subscription resolver, and that's what we also wrote with the onReceive. But in this case, it's the onPriceChange resolver here. And this time we not declare this topic, because we say, actually, we subscribe with, and we use the name of here, with this stream. We use this stream for our events. So whenever somebody subscribes here, we hook up to this stream, and then we're gonna yield the price objects back. So this guy here yields a message back, this event message that you can see here. And we use then a data loader again to have a low impact on our database, actually, to yield back then the actual object. Let's just run that. And I have one more awesome thing. And then we can do questions if you guys want. So here's the onPriceChange. And I want to always notify it when the price changed for a cryptocurrency. And this is essentially the same object. You can see asset price here. Let on price. You can actually see if I write my query down here and then go into the assets and go into the nodes and then go into the price here. This is the same object. So this is the asset price object, same object up here. And that's why it's so appealing. It's not a separate thing where you have to think about pub/sub. It's just a real-time query where you get data live streamed in. And that's beautiful with GraphQL, makes these experience in these applications with all these updating things possible. Okay. Let's go over that. That was the theory. I explained that. We have an event stream internally, and that event stream triggers the executor, which then transforms it into, in this case, into the asset price object and returns it to the user. We did that. Things you have to think about is with subscriptions, scaling. If you do sockets, you have to really think about scaling. I mean, we have customers that have more than 500,000 messages per second and work well with that. But you have to think about, like, there are hooks in Hot Chocolate where you can drop connections, for instance, so that your clusters rescale and things like that. So there's more to it than just running a simple web server. So this is a feature. So I'm a GraphQL TSC, so I'm actually one of the members at the GraphQL Technical Steering Committee that write this spec. And this is something we are working for 6 years now on, or more. And actually, Hot Chocolate implements it. It's one of the first GraphQL servers already for 2 years, actually. But now we are very close to release. It's in a draft specification now. And it's about one of the weaknesses of GraphQL, essentially. Let me show you that. So the typical thing is, when we fetch everything in one request, then our application performance could also have a problem, because we are as slow as the slowest thing in our GraphQL query. But this is going to change. In our thing, the slowest thing was actually the price thingy here, where we went to the REST service. That is the slowest interaction that we have with our REST API. And it's not because REST is inherently slow. It's just I made this piece of the API deliberately slow so I could make this demo. Okay, in this case, actually, this is also now coming from our REST API. You can see this is actually the API, a couple of iterations ahead again. And we're going to make that fast. So let's first run this query and have a look at that. So I'm running this query, and you can see it's 2 seconds, which is slow. And you would feel that. That is essentially when I call this application that I showed you before, what makes it slow, that the REST service sometimes is slow. So what we can do now, actually, in GraphQL is say we want to stream this part. We want to have this initial, so we want to have the initial item first. So one item of this list we want to have immediately. And then we want to have these parts deferred. And then will give us them later as the execution engine has them available. And think about the example here. If I go here, this application loads, but it actually also has here the ability to scroll. You can see I can scroll through the site and see all the graphs here. But when the user first comes to this site, we actually just see the Bitcoin. And it could take a couple more milliseconds to resolve these others. We don't care. And this is essentially what Stream expresses here. Give me the Bitcoin first, and then give me the other things as they become available. So if I execute that now, I'm 172 milliseconds for the first response. It takes still the same time to resolve the data, but it's being streamed. And now I have all the benefits of a single HTTP post request. It's HTTP post, works for HTTP 1.1. And then I get it streamed. You can see here I receive patches. So I first get here the Bitcoin, just the price. Then I get a couple of other things because they are cheap to resolve. And at some point, we actually get the data from the REST service, which is expensive. And you can see down here in the responses, we have the patch pass. So where we have to patch this in, this has to be patched into element 9, whereas this has to be patched into element 2. So you can see it's not really ordered. The execution engine resolves them as they become available. Okay, because I am so much over time, just let's spin over that. I would have explained how that works. One cool thing here, and you can read that. That is a bachelor project that actually looked into GraphQL in the .NET ecosystem. And they went into that by saying, okay, actually, we expect that REST APIs are faster than GraphQL APIs. And you can read that through, actually. But the result of the experiment, and they did a lot of benchmarks, all open source, you can have a look at them, is that they found out that Hot Chocolate is not only the fastest GraphQL server in the .NET ecosystem, but it outperformed the REST API that they built with controllers. And that is because, like in the typical use cases, GraphQL is always optimized for the use case that you have in your client. You never overfetch. You never have to do multiple fetches. And so you, on average, have better performance if you use GraphQL in a typical setup. And that's also why big companies like Twitter, Facebook, Netflix go GraphQL, and also Microsoft, like Teams, for instance, GraphQL, or Office is on GraphQL. And that's also what they looked into, like how many lines of codes do you need for REST or for chocolate with the same for the same use case that they implemented. And actually, if we didn't have to create a clean mutation class in GraphQL, we would actually be less code. But since GraphQL is more structured in the way that we have a mutation class and subscription class and things like that, and you don't put all these things into one class, we have 2 more lines of code than the typical REST API and 1 class more. But apart from that, it's a good thing to use GraphQL. I encourage you to try it out. And as a conclusion here is GraphQL is really rapidly evolving with a ton of new features coming in the next spec version. And if you look back at the beginning, when Facebook started with GraphQL, they only had query and mutation. Then in 2016, they introduced subscriptions. They actually outlined already these experiments around stream and defer. It just took the specification committee another 6 years to figure it out. But there are other things like coming to GraphQL now, like error boundaries. I didn't have time to go into that. Like query error boundaries, where you can rewrite nullability from the client side. So the consumer is really a centerpiece for GraphQL, and we put the consumer front and center. So with this, thank you. It was a lot of information, I know. I had too many slides and too many things I could have also shown you apart from that. But anyway, you can follow me on Twitter or on Mastodon if you want, whatever makes you happy. If you like what you've seen, please help our community by starring us on GitHub. We are open source. We are 100% MIT, so it's all free. You can take it and do something with it. And with that, I'm open for questions if there are questions. And I'm sorry, 20 minutes over. So, okay, the questions are in the Discord chat. So he said that to me in the beginning, but you know, when you are in the zone, then you're in the zone, you don't listen. Let me go over here. Oh my God, I have so many messages open. I hope is it the there must be something. Let me ask which one is it. Message. I heard the ping. New mentions there. Thank you. Is it this one? Solution chat 1. Ah, thank you. It was the other one. Okay. Let me figure out what the questions are, and then we can go through there. I was actually trying to develop something like myself. Okay, this is an actual. Do you think MS should integrate GraphQL into ASP.NET Core to also boost adoption? I don't think that, because I'm an open source maintainer, so I think I want to have what people have in the JavaScript ecosystem, where you have a lot more traction on these things. You have a lot more tries to do things, and in the Microsoft ecosystem, it's often that Microsoft takes over the space, and then people just want to have this from Microsoft, and that essentially kills all the open source around it. In our case, I have to say, Microsoft didn't invade our space. We are talking a lot to them, and they let us build. While Microsoft is building something around GraphQL, it's not a GraphQL server in that sense. You can already try it out. There is like this API management where you then have essentially in Azure, you can integrate Hot Chocolate there. But apart from that, the entity framework team and all the other teams in Microsoft help us to create these experiences where you have these projections and things like that. So it's actually a work together with Microsoft. So so far I enjoyed it quite a lot, and I think we should really have more open source in .NET. Will GraphQL replace REST? That is a typical question, and I don't know if this should be, because there are certainly use cases for REST, or you want to maybe have both for certain things. While GraphQL can solve most of the things that REST can do. Like GraphQL is not good with binary data, for instance. It's good with data. So typically when you serve like files, you would return a REST URI to a REST endpoint and serve it there. But in general, it's always, there are multiple technologies, and it also depends on what you like most. There's also gRPC. I mean, they have slightly different use cases. So if you look at the typical GraphQL setup with a proper business layer and stuff in there, then, for instance, Twitter, we have GraphQL on the top, then Thrift services beneath that, so Thrift microservices. Netflix is essentially the same. There are also companies that do GraphQL on the top and gRPC beneath that. Depends on if you're a bit more .NET or if you have a Java infrastructure down there. What is the DataLoader to solve the N+1 problem? The DataLoader is resolving the N+1 problem. I should have said that in the demo, actually. It's essentially where I fetched this list of assets. And if I had more time, I had expanded that more. But I would have fetched then like 10, like if I fetched 10 assets, I would have fetched 10 times this REST endpoint. And by using the data loader, we are batching this together and just do one call. So it's kind of solving a couple of these N+1 problems. What resources can you recommend for people that are interested in getting into ASP.NET Core and GraphQL? So we have a ton of resources, actually. So we have this YouTube channel. And I have to give a shout out to Nick Chapsas on this, because if he wasn't there, we wouldn't have this content. He pushed me essentially into doing this because it is much easier for people to get into it. You can see we have a ton of videos that go into specific things about GraphQL. For instance, today we released optimistic updates with Blazor and GraphQL, how to do optimistic updates with mutations there, how to test GraphQL, uploading binary files with Blazor and GraphQL. So there's a ton of topics around that. There's also like the Chili Cream homepage, where you can find documentation around banana cake pop, around hot chocolate, or strawberry shake. So a ton of resources here. Do we have more? Is that all? There are a couple more questions. The learning curve seems steep. How much time would you suggest to get a hang of it? So actually, it is not so steep. I packed so much in the talk. you saw the basics. So in the beginning, you will build basic GraphQL servers. They will not have real time. They will not have all the fancy shit around them. They will just fetch data and mutate data. That's a typical way how I would start with them. And then it's just taking your business layer and exposing it through your query type and let Hot Chocolate infer this thing. And then you have essentially your GraphQL API. There's a lot more to that as you go along. And what I would do in the beginning is follow the best practices around GraphQL. And that is implementing essentially the relay specifications, like the cursor-based specification that I showed you how to implement that. And it doesn't just work over queryable. We actually also let you inject all the skip and take things into your resolver. You just annotate it, and then we inject how much you have to navigate. And also these filters can just be injected in your resolver, and then you can pass that, map that into your business layer and pass it along. So, I would suspect that you take at least 2 months until you are a GraphQL native. And you will learn all the time along. So the first time it's a bit stumbling, especially with these more advanced concepts. But to get started, it's super quick. I would say it's easier than REST. Think about this first example. It's just putting a class in and then writing methods in there, and they become your GraphQL API. Not sure to understand how subscriptions work under the hood. Is it opening a WebSocket or something else? So it can be both. So it can have a WebSocket. Let me show you one thing here. That is, again, Banana Cake Pop. And we have here, for instance, this workshop template. And when I go here in the settings, you can see that I have the subscription protocol is set to auto. It can work over WebSockets, and there are 2 WebSockets protocols out there that are used at the moment. The Apollo protocol is actually deprecated, but we still support it. But there's also the newer GraphQL WS protocol, and then there is GraphQL SSE. And GraphQL SSE essentially does a simple HTTP post call. So if I would do a subscription here, let's see on price change here, and we're gonna take again the price. So that's my server that I have hosted here. And if we just get the developer console in here, okay, and clear that, and now run that, you can see that is real time. So you can see new stuff is coming in. I could go always to the new stuff, and you can see this is actually a standard HTTP call. So that it's a 200, it's a post call, and it's just of the type text event stream. And that is essentially a server-side events call that we have. So it doesn't have to be subscription. It doesn't have to be a socket. So you can use that over HTTP. One thing here is that Chrome has a bug that they not gonna fix for HTTP 1. That's why I always say if you have HTTP 2, or you can guarantee that your clients are HTTP 2, use GraphQL SSE. You could also have a bridge where you switch between those. The beauty of this is this SSE stuff works over most firewalls, and so easier to scale and things like that. But if you run it over HTTP 1, you can only open 6 connections. You can only open 6 connections from your browser to the backend. If you do HTTP 1. If you do HTTP 2, they multiplex that, and it's not a problem. So with Microsoft's architecture, would you implement one GraphQL API per service, or so? This is actually, so there's a longer version to my presentation. Where we go into federation and things like that. So the typical thing I tell people in the beginning: build a monolith. because you are anyway learning GraphQL. So just start learning GraphQL. And as you go forward, and if you have more than 8 people that are working actually on this graph, then it makes sense to federate it. So what does that mean is, let me just quickly get this other slide out, and then we can have a look at it. Okay, and here's a typical architecture. That's actually from Netflix, the Netflix architecture. They also started with the monolith. Then they over-architectured and started with lots of microservices. And then they compensated for that by putting a GraphQL layer in front of it. So essentially, they have a GraphQL layer in front of their microservices. But if you have, as I said, multiple teams working on that, you might go into something like that. That's a federated architecture where you have like domain GraphQL servers that cover one certain domain and is handled by one team. So it's not about putting things into boxes because it's getting a lot more complex. So don't do that if you just want to have one box for one thing. It's for when you have like really a team of 8 people that work on this guy, and then you have another 8 people working on this guy and things like that. Then it makes sense. And then each of these cover one certain aspect of your graph, and they then use down there these microservices. Okay. This guy is covered. What is the minimal experience to implement any GraphQL API? Minimal experience, you mean like the minimal time to do that? Depends. What is the minimal time to build a REST API? I would say you have the same, you will take the same time. You have to implement the same security concepts. So it's essentially, you cannot say it's faster than this or faster than this in the implementation base, because in the end you face the same problems. Just that you focus on a different aspect on them, but you still have to do identity stuff. So you still have to implement security. And you have to also think about other things. I didn't speak about security in the GraphQL concept here. In my bigger talk, that is more, it's actually a workshop over 2 days. I talk about these things in detail, how to solve them. If you saw, for instance, GitHub's API, they have a public GraphQL API. And they implemented a couple of security concepts around that, like rate limiting and stuff like that. But the typical GraphQL APIs like Netflix, they are not open. They are public in the internet, but they are not open to us. And they do essentially a shortcut. Let me show you maybe Twitter. Good example. If we go here, again, developer tools, allow notifications. Let's hope it comes back because Twitter is behaving strange. For instance, this tweet, let's like it. And then you can see there's a call, favorite tweet, and this is actually GraphQL. But it's a secured GraphQL server. So we only have these hashes. We don't send over the queries anymore. We just send over these hashes. But if we look at the response, this is a GraphQL response. We have data, and we have here the response of this field. So what they do is essentially when we compile our front end, and you can do the same thing with Strawberry Shake, when we compile this front end in our DevOps pipeline, we would strip all the queries, then put in the hashes of these queries, and then you have the fastest, most optimized REST endpoint ever built with GraphQL. And the thing is, GraphQL gives you all this flexibility to build your experiences, and then you can have all the security and predictability that you have with REST as well. So it depends on what you're going to do. So are you building a public GraphQL API like GitHub is doing? And public means somebody else outside of your company is using that GraphQL API to integrate, or are you building a GraphQL API just for your own applications like Twitter is doing? Okay, that was a very long answer for this question. How do you deal with versioning a GraphQL API? You don't. We don't version. GraphQL works more like C#. You don't version there in the sense of, if I break an API, I would not branch my whole API. I would put an obsolete tag on it and deprecate it. And that's the same thing we actually do in GraphQL. We deprecate parts of our API. And that is answered. This question needs to be answered. Can you tell us the story behind the name of hot chocolate? How do you... Okay, this is the story behind it. So actually, if you go back and look at the first commit of hot chocolate, it's called Zeus in the beginning, and that was our project name. But we were looking for a name, and I always liked how the JavaScript guys name their things. They are so not like .NET is a bit enterprise. Yeah, we try always these dry names, like very essentially just the thing. gRPC is gRPC or whatever. But in JavaScript, we have all these nice names. So it happened to be that me, my brother, and my son were at Starbucks. And my son, then 3 years old, said, while we were discussing this, how should we call that? And he was just saying, I want a hot chocolate, Dad. And then my brother said, let's call it hot chocolate. That's how we called it, hot chocolate. And from this day on, we are taking the US Starbucks menu, and every product is on the Starbucks menu. So banana cake pop, they have these cake pops. It's essentially, if you're in the US, you know what a cake pop is. It's a cake on a stick, like a lollipop. And you can buy them at Starbucks. And also strawberry shake. They have these strawberry shake is also from Starbucks now. From your experience, what is the biggest barrier out there for companies to use GraphQL instead of REST? It's education, I would say. So most companies I work now with do GraphQL. And if you have any insights into Microsoft, you would know that they are also pretty much betting on GraphQL. Just as I said, just with Twitter, you saw Twitter's using GraphQL, but most people don't know that. Microsoft is using for a lot of products GraphQL now. But GraphQL APIs, as I said, most of the times are private. Facebook's GraphQL API is as well private. Private, again, doesn't mean that it's hidden somewhere away. It's just that these are optimized, like I showed you a couple of minutes earlier in this in Twitter. Essentially, we compile them at the end of the day into a very high-performant API. If you have high churn of changes, does that not mean you're ending up with models that potentially have many obsolete properties? So you have to think more about graphs. So like in a GraphQL API, you would think more about types. So you wouldn't do this changing this way. It depends. So there are two things to it. There is this thing where you have a web application. And with the web application, if you only have a web application on your graph, then you actually, and you're your only consumer, then you don't have the problems there so much, because you can introduce a change. Essentially, essentially how you would do it, you introduce a new field. Maybe it's called now a hello1 because you want to replace the hello field. Then the client team would adopt this hello1 field. The old field would be deprecated. And then you would swap. You would introduce a new hello field that is now the hello1 and swap that around. That's a typical how you would do that in a web environment. But to be honest, favor no change. And Facebook, for instance, they have one of the biggest graphs that I have ever seen. It's 10,000 types, 300,000 fields, and a ton of arguments. And they have all their applications in one graph, like WhatsApp and Facebook and all these things. And they have never removed a type. So they only add. And that the reason for that is that there are a ton of mobile applications out there that are still that might not be allowed to upgrade, because they are on a very old device. Somebody that maybe cannot afford a new device, but this person is still consuming Facebook's ads. So why should I deprecate him? So you think different about it, and you think more deliberately about your API. How to get that auto-completion in CS code terminal? You mean, okay. So you might be possible on Windows 2, but I'm on a Mac. I actually started. I moved to a Mac. First, I moved to Linux to build Hot Chocolate, because we started building Hot Chocolate with .NET Core 1.1, and I wanted to prove that you could actually build such a project on Linux. But Linux was too much work for me, so I switched to Mac. And on Mac, we have Setshell. And there are a couple of tools that you can install in it. Is essentially, I think you have kind of cloned this posh git stuff or posh shell, but it's more powerful and it has all these IntelliSense and stuff like in the console. So if you're on the Mac, I can give you a link. Or if you're on Linux. With that, I would say thank you. Thank you, guys, and try it out. Have fun.